Hey, how you doing? This is Kitch, and you are watching me play Factorio. One of my flaws that I have as a content creator is that I sometimes assume that the viewer, which is you, have watched every single Factorio video that I have ever made, and you have all that context in your brain as I go through and explain things. And I realize that that's not realistic. I have hundreds of Factorio videos out there, and some of you have watched them all, and you are awesome. But most of you haven't, and you're awesome too. And some of you, this may be your first or second Kitch Factorio video, and you're awesome as well. But I just want to kind of review what I mean when I talk about sushi setups, and just provide a little bit more detail. I have a series out there that's called Factorio Creative Mode, Factorio Creative, I think it was. It was one of the series that I was stalling time with, just waiting for .17 to come out, where I loaded up the creative mod and just went around and built some designs. And that's where my fascination with this stuff kind of started. But I go into excruciating details with many sushi setups, and there's also some good combinator stuff that I get into there. If that's something you're interested in learning about, there's probably 4 or 5 videos where I go kind of in depth with some of the combinator stuff, at least my understanding of the combinator stuff. Take that as you will, but I just want to kind of give like a high level. So in the first video, I kind of mentioned a sushi setup. This is a sushi setup where we have one belt going around that has all of our items on it, and this just pulls stuff off of the belt. Now, there are a whole bunch of different ways to do sushi, and sushi science in particular, because sushi science is one of those, it's actually not that difficult to do, because all of these require the exact same number of things, right? We have a set number of items coming in, and there's a set number amount, and everything takes the exact same thing. So there's a lot of setups that work for that. The setup that I'm using here is, could be argued that it's a little bit overkill. But the one thing I do like about my setup that a lot of those other setups do not offer is that it is very adjustable, and all the inputs don't have to be even. We can do several different things, and I showed this in that creative mode wherever we were making red and green science with a sushi setup. It worked out great, and I've seen some other things as I've looked around the interwebs where some folks have been doing pretty extensive setups with that idea, and that is awesome. So that's why I like this. The basics of the way this work are, I have some counters here that count stuff as it comes in. These are just wires that are set to the belt. They read the amount, they count the amount that they let past, and they only let past a certain amount. In that case, this is S. S is just a signal that I have here. It's currently set to 40, but I can adjust that from here to say I want more or less. And basically all these are controlled by S. So we're trying to keep 40 of each science pack on this sushi belt. This is fed via a green wire into this combinator right here that is just taking each signal, adding 0, and outputting each signal. And it's wired the output to the input. So this is basically just a memory cell or a counter. And this is counting the number of science packs that are put out on the line. As they get added, that increments this counter number. All of these inserters are hooked up to a red network that is reading the hand contents. And as they pull the science out, that pulse that is generated is sent on this red wire. That goes into the back of this combinator that takes each signal, multiplies it by a -1, and outputs it again. So we are subtracting that from this counter right here. This is fed into the back of that. So as we add packs, that gets added here. As we get packs pulled off, that signal's coming back and subtracting from this total. And they are all trying to keep 40 of those on the belt. And that's basically the way this sushi setup works. We can go through and adjust these individually and set different amounts if we want. And it doesn't matter what's coming in. We can use that setup generically for everything. It looks like we're running a little low on purple science right now. So, yeah, with that kind of review, and again, if you want to get a lot more detail into this, do check out that creative mode series that I did. I spend a lot of time on sushi setups and circuits, as well as trains for some reason. An unhealthy obsession with sushi and trains. Okay, let's just take a look down at purple science and see what the holdup is there. It is currently red circuits, which we're using those. I updated these machines to the green ones and threw some speed modules in here as well. How are you doing? You have 8 now. Put those in there. Actually, let's take all these out. And let's get them in these machines. And we'll build it going that way. Red circuits, what's going on with that? Where are all my reds going? Oh, we're just not making enough of them. Ah, well, we'll worry about that another day. All right, so let's get kind of a template set up here with what we want to deal with. We definitely want to use beacons. We definitely want to use assembly machines, and I think that's in the right spot. It is. And we want to do 2 rows of beacons. This is the way I typically do like a beacon setup. I'll have a row of beacons up top, a row of beacons up bottom, and a group of factories or assembly machines tied in really close together. I like to do this because we can take the next row down like this, and we recycle this row of beacons right here. So we're getting 2 for 1 on that. That's kind of my thought there. Now, I'm wondering if this is what I want to do. I did my calculations based off of the 16 or 8 beacon setup, 16 speed modules, and that has got me this. And I know there's just like a lot of single factories, but there are a couple of them that are like 3s and 4s. I'm wondering if we did the full setup, if that would change things. Let's see, that would be something like... It's that, right? That would actually be 24. And we could have a belt running like this, and a belt running like this. We could have a belt running like that. That would give us 3 belts. We'd have to do that, 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 that. Yeah, we wouldn't be able to fit anything else in there, though. Unless we could maybe do like a braid kind of thing. Hmm. I don't know. I'll have to run the numbers to even see if that is worth it. Because what would that give us in the end? It might give us one less blue machine. It might give us one loaded city structure or 2 loaded city structures. It's going to shave off a little bit. But I don't know. I'm more concerned, I think, now with the amount of belts that we can get. And what I mean by that is I think if we set it up like this, we can get our top belt, we can get our bottom belt, and where we had 3 before, we can actually get 5 with this setup. So we could pull in off of this side and then send out off to that side. That way it could pull off of all 5 of these belts, and it could place onto all 5 of these belts. And that just gives us a lot more options. And I think I like that a little bit better. All right, so if we copied this and pasted it over like that, and we continued this beacon line, that's not going to work because the beacon and the assembly machine are lined up, so we'll have to go ahead and offset that. Okay, and that basically is a mirror of this over here, because this is just barely touching on that end. So that means that this should be our pattern. Let's take that out to the end, take that out to the end, take that out to the end, that out to the end. So we can copy this, and that'll paste right there and work. Or we can paste it right there, and it'll work. Nice. All right, so that's our pattern. We're wasting a little bit of beaconage there, but we're able to save 2 beacons per machine and reuse those. So that's a little bit better than not. Okay, so that looks good. Let's get power down here because I'm tired of seeing this thing blink. We can do something like that right there. No. We want to leave the tops of those open because if something requires fluids, we want to be able to bring that in on the top there. So let's put that maybe there. And there. And this will be like that right there. That'll be those lined up. And that seems to work pretty good. Very good. All right. And just line up those power poles. That'll give us our tile. Line up those power poles. That'll give us our tile. Fantastic. All right. So this gives the ability to pull off any of these 5 belts coming in, and that's good. That's what we want. This has the ability to send out to any of those 5 belts. Now, I'm a little bit concerned because this inserter is always going to send out to the outside of that belt. That one's always going to send out to the outside. They're all going to send out to the same side of the belt. So that has the potential to get some lane ugliness going every now and then. We might, you know, we might have something like this. We're going to have to set up some kind of, like, balancer. Both lane balancers as well as balancers. What is like a, what does like a 5 by 5 balancer look like? It's not pretty. It's not pretty at all. But it'll be fine. I know there's some blueprints out there that have the 5 to 5 as well as the lane balancer. This right here is a lane balancer. And that is different than some of the other lane balancers out there. Like that, or there's also one I've seen that, and I've used before. I think I'm actually using it in the Sushi Science setup. That looks like this. This works, but it's not a true lane balancer. This is a true lane balancer in that it actually pulls. This will distribute evenly, and this one distributes evenly. The difference is that this one will actually pull evenly from both sides as well, where this one will not. It'll just pull in whatever's coming in and send it out. This one actually pulls from both sides evenly, so it works out a lot better. But yeah, we'll have a big contraption that has the lane balancers as well as the line balancers, the belt balancers, and the lane balancers. Yeah, that's gonna be something we're gonna need. Anyway, back to the setup here. I think this is pretty good. I want to go ahead and add in some things that we're going to need here. We're going to want wire networks running here. Probably both of them. And I think I'll keep my convention that I had earlier going in that the red, we'll use that for the taking away. And these inserters right here that are grabbing stuff are going to be taking away. As are these guys right here. Okay, and we don't want you to enable disable. We just want you to read the hand contents on a pulse. Same thing with all of you guys. And you guys are going to be our green inserters. And the green inserters are going to go onto the green network where they are going to add stuff. Okay, so you are going to enable disable. You're also going to read the hand contents. And well, there's a couple ways we could go about doing this. Like, let's say, in theory, this is making gears. And let's say we want, I don't know, 100 gears on the line at any given time, right? So you guys are going to keep going while gears are less than 100. And we can set that up that way, and it'll be fine. That's going to read the amount of gears that are on the green network, which is going to have our total. What I would like to be able to do is set up something. Okay, so we're going to have like a couple of combinators over here, right? This is what it's going to look like at the end of the day. Let's see, will those two reach? I don't know. We'll just put that there just in case. There we go. Okay, so the red signal is going to come here. And it's going to go into the back of that combinator. The green signal is going to come in, and it's going to go into the back of that combinator. And you guys are going to be our everything plus 0 output each. Not everything. And that's going to be our counter. You are going to take each signal coming in. You're going to multiply that by a -1 and output that signal and feed it into the back of that combinator. So that will be our subtractor. And that'll just be our totaler. So we can set all of that. Trying to think of a way. Okay, so what if we ran another network down here on these poles, and it's a red network, but it's not the same as this red network. It's a different red network. We can't hook it up to these inserters, but we can hook it up to these inserters as long as we don't go back. So this red network is going to be fed from a constant combinator where we set up what we want going out. So let's say we wanted 100 gears. And that is going to go out on that network. So we'll have a signal of 100 gears coming out. That is the total that we want. I could set that to like a variable instead of that. I could say one of those things, but I'll never remember what that is. So instead, let's take a combinator. An arithmetic combinator. And we'll take that down and feed it into the back of that. And then we'll feed that into all of those inserters. And what we'll do is we'll take gears plus 0 and output A for the amount. And we'll switch that to A, gears less than A. So now and if we go through here and take this signal off, that should disable all the inserters, and it does. And if we turn gears back on to 100, that'll be that right there. All right, that is that. Gears plus 0 output T, that is the total, and then we send that out to there. We can say a total is less than the amount. and send that all the way around like that. So basically we're using these arithmetic combinators as signal converters. And I don't know if this is easier or not. But instead of having to set up all these individual inserters now, we just have to place one of these down and we say, you know, you make gears, which I think you already were. Let's turn all back on. We set that to gear, we set that to gear, and then that is ready to go. And then we can adjust the amount that we want just by sliding this back and forth. And that'll control that, no matter how many gear machines we have, no matter where they're located on the network. For gears, you know, not such a much, but for the red circuits and like control units and rocket fuel, we'll be able to control that from one spot as opposed to everything else. And this one right here is just so you don't have to set up gears in all 5 of these. We just have to set it up in one place. I don't know. Is that going to work? Maybe. That's going out on a red network. That's going out. And we're not getting any adding going on here, so there's none of that. So that looks good. All right, well, I think I'm going to try to go ahead and maybe move forward with this design, unless somebody else has some ideas. I'd love to hear them. I'm not using any guides on this. I'm just trying to figure this out. I haven't really reviewed anything else other than the other sushi setups that I've looked at. But yeah, no, I'm just thinking, the idea that these are our 5 sushi belts coming around. That's our sushi belt. It's going to be 5 belts wide. We set our controls from a distance. We set our counts from a distance, and we control these inserters based off of that count. There's only going to be one of these. Only going to be one of these, and only going to be one of these. Well, there actually may be multiple, depending on how many items we actually need. But we may find that we need more or less of an item actually out on the belt, and it'd be awesome to just have one place where you could go through and control that. This, I think, may be overkill. This one, I think, actually is going to be necessary. Anyway, thank you very much for watching. Again, would love to hear your feedback or any ideas that you have. Thank you very much for watching. I really appreciate it, and I'll see you next time. Have a good one.